This video is for my pre-calculus students. We're going to be doing lesson 41 today. I'm on page 209. And first thing we're going to do is graph a tangent function. When we were in the green book, they showed us a tangent function and a tangent graph. We did not learn it there. Excuse me, I dropped something. So we're going to learn it now. Right up here, I know that tangent is equal to sine over cosine. And so when we graph it, anything in the numerator, we learned the other day that if there's, we've learned it before, but we talked about it again the other day. Wherever you have a 0 in the numerator, that's going to show up on your graph. That tells you where you cross the x-axis. So right here, here's a sine function, and the sine function crosses the x-axis at 0, at 180 and 360 in the first cycle. That means that my tangent function will also cross the x-axis at 0, 180, and 360. Now cosine is in the denominator, and we learned that whenever you have a change in x, like x minus 1 in the denominator, that means you're going to have a vertical asymptote at positive 1. You're going to have a pole there. So wherever this crosses the x-axis, it doesn't give us another place to cross the x-axis. Wherever this crosses the x-axis, that's going to give us a pole on this graph. That's only because cosine is in the denominator. So we have a 0 at 90. I have a pole at 90 for the tangent function. We have a 0 at 270. I have a pole at 270. Now, how do you know where to go? Which, here, do I go up or do I go down? Well, if you were to plug in something like 45 degrees or whatever, if you plugged in 45 degrees and took the tangent of it, you'd find that it's positive. It's up here. So and 46 would be higher than that. So this is going higher, and it comes to this pole, and it must go to infinity. Coming to the left here, as I approach 0, it must cross there and come down here. This is going up to positive infinity. So this is coming from negative infinity, must cross there at 180 and go on up along that pole. Again, going up to positive infinity, so we're coming from negative infinity and going like that. There's your basic graph of a tangent function. We'll come back to this in a minute. Now, if you turn the page, and at the top of page 210, they give you 3 very important rules for reciprocal functions. We're not going to read them verbatim, but very quickly. Number 1 says that if you have a function that has a 0 in it, the reciprocal function will have a pole at that same place that the original one had a 0. And if you have a pole in your original function, in the reciprocal function, it will turn into a 0. Okay. The second rule there says that any place that this graph crosses the y coordinate of 1 or negative 1, it will be in your reciprocal function also. Let's illustrate this, and we'll get to rule 3 in a minute. Because the cosecant x is the reciprocal of sine x, or sine is a reciprocal of cosecant, 6 1/2 dozen of the other. When you go to graph cosecant x, we look at the sine x function. And it says, okay, we've got a 0. The sine function crosses the x-axis at 0. Because of that, the reciprocal function, cosecant x, will have a pole at 0 degrees. I'm going to draw it like that. Okay. At 180 degrees, there's a 0 in the sine function. That means at 180 degrees, there will be a pole on the cosecant function. Sine has a 0 at 360. Cosecant will have a pole at 360. Also, wherever there's a pole in this function, this will have a 0. There are no poles in a sine function, in a sine wave. It never hits a pole. It just keeps going up and down through infinity. Because it has no poles, that means that the cosecant graph will have no zeros. It will never cross the x-axis. Okay? Now we need to look at the second rule at the top of page 210. The second rule says that wherever this original graph has a y value of 1 or a y value of -1, excuse me, your reciprocal function will have that same point. This is going through 90, x is 90, y is 1, at x is 90, y is 1. It will pass through that also. Right here at x is 270, y equals -1. At this 270 right here, there will be a -1. And it goes like that. Now, to graph this, I know I've got to go through this point, but there are no zeros up here, so I would come and go down like this. That's going to a negative infinity. We're going to come from positive infinity. It must go through that point and back up along that pole that I didn't extend far enough. And it'll be over here also, like that. Let's extend these poles just a bit. Like that. We'll put one more over here. There's going to be this over there. Okay? That's example 41.1, middle of page 210. 41.2 says to go graph a secant function and a cotangent function. We're not going to fool with the secant function. Just like a cosine wave is just a sine wave moved over 90 degrees. A secant function, make sure I get that right. Yes, a secant function is just a tangent function moved over a little bit, moved over 90 degrees. They show it in the book, middle of page 211. Excuse me. I want to focus on the cotangent function for the rest of this video. Here's a tangent function. Cotangent is the reciprocal function of tangent. Cotangent is 1 over tangent. So, here is my tangent function. The reciprocal function, wherever there's a pole in this one, we'll get a 0 in this one. Wherever there's a 0 in this one, we'll get a pole in this one. So, let's keep them the same color. Wherever there's a 0 in the tangent function, we will get a pole in the cotangent function. So we're going to get a pole at 0. We're going to get a pole at 180. We're going to get a pole at 360. Likewise, wherever we have a pole in this one, we'll get a 0 in this function. 90, there's a pole. In this one, 90, we get a 0. 270, there's a pole. 270, we get a 0. So there we are. Now, looking at this, does my graph go like this? Or it's not even sure. Does it go like this or like this? Who knows? Well, one other thing. Rule 2 at the top of page 210 says that wherever you have a y value of 1, that point will show up in the reciprocal function. Where you have a point of -1, those points will also show up in the reciprocal function. So here I cross through 1 at about 45. So here's 90 at 45. I'm going to pass through that point also. Here at between 90 and 180. Somewhere between there, I don't even know what that is. Well, add 45. 135. At 135, I'm going to be down at -1. I'm going to be right there. And midway, add 45. At 225, I'm going to be right here. So if you look at this, it's not this, it is this graph coming out. And then like this. And it just keeps going like that ad nauseum. Right there. And we see that the tangent function is going up and to the right. This one's going up and to the left. And it's been shifted a few degrees also. Okay? So poles, zeros, reciprocals. A lot of good information here. We'll continue this in part 2.